Alright, how's everybody doing today? This is Mr. Muscarella coming at you, and in this video lesson, I'm going to show you guys how to find exact values for inverse trig functions. Now, one of the first things we've got to understand is what each of these types of equations means. There's one meaning for the equations on the left, and there's a different meaning for the equations on the right. And understanding the difference between those two is kind of critical for this section. Now, one of the things you want to notice is that on the right-hand side, those are the inverse trig functions for their corresponding trig function on the left-hand side. Now, on the left-hand side, what we're going to do first is we're going to take a look at that y. And what that y is going to represent in this case is going to be the trig ratio. Now, still on that left side, the x then is going to represent the angle. So when you look at this type of problem, the trig ratio is what the y is, and the angle is what the x's. But if you take the inverse, remember when you take the inverse, you switch the x and the y properties. But even though it's still written as y equals, that just means the y now is going to represent the angle and the x is going to represent the trig ratio. What this boils down to is two critical ideas right here. And that's the answer for a problem like y equals sine x, y equals cos x, y equals tan x, any of the trig ratios that are set up like that, your answer is going to be a ratio. Whereas when you're dealing with an inverse trig function, your answer is going to represent an angle. So those are two key ideas when working with these types of problems. You've got to learn to speak like a mathematician. And when you see this expression or this equation, y equals, and then sine with a little what looks like a -1 as an exponent and then the x, the way that you describe that, the way that you speak that is you say arc sine of x or inverse sine of x. And the same thing is true for each one of the other trig functions. You would say arc cosine of x or inverse cos x or arc tangent of x or inverse tangent of x. Those are the correct ways that you want to describe those symbols when you see those written in an equation. Now let's go ahead and take a look at this function y equals sine of x. Now if we were to draw a horizontal line about right there, we could tell from the horizontal line that it's definitely going to fail the horizontal line test, because if we were to move that horizontal line up and down, it touches the graph in more than one spot, therefore it fails the horizontal line test. Now what does that mean as far as our inverse? Well, you should remember that if a function fails the horizontal line test, it's not one-to-one, and therefore it would not have an inverse. So we didn't like that. So math people were like, hey, why don't we just go ahead and restrict our domain to just this spot right here? They talked about it for a while, and finally most people agreed that we're going to restrict the domain from -pi/2 to pi/2. And it's going to include those values. So that's why we're going to use a hard bracket there. So -pi/2 to pi/2 is going to be our domain that we're going to use here. Now, because when you have an inverse function, the domain and range are going to switch. So the domain of sine of x is going to become the range of the inverse sine of x. So that's going to go from -pi/2 to +pi/2 with the hard bracket, because that's going to mean that it includes those two endpoints. Now the range piece of it, the range, that's kind of easy to see. You start down here at -1 and then you end up at +1. So your range is going to go from -1 to +1 for sine of x. So again, we restricted that, and that is also going to be the same thing as the domain for inverse sine of x. Now, what does this all really boil down to? Because for a lot of people, you're going to take a look at this function, and what you're going to have to do is kind of work with this piece here. Now, from -pi/2 to pi/2, this piece right here, and I know we're looking at it in a linear format, what that's doing for us is we're taking a look at just quadrant number 4. So when we get answers, our answers are going to be in quadrant 4. Now the other piece of that is up here between 0 and pi/2, which means that is up in quadrant number 1. So when we get answers to these types of problems, we're going to look for things in quadrant 4 or quadrant 1, which is going to make us take a look at these values here on the right hand side in this table of values that you should have memorized from the unit circle or from reference triangles. But go ahead and fill out these values here, because they're going to come in handy in a little bit. So go ahead and hit pause, fill in those values, and then let's double check to make sure that you got them correct. So how'd you do? Hopefully you got all those values correct. Now one of the things that I want you to know is because sometimes people freak out like, oh my gosh, there's so much to memorize. If you can recognize that there's symmetry there, you only have to really memorize one half of that table. Maybe the top part from -1 to 0 or -π/2 to 0. And then the bottom part is just going to be the same pattern. So don't stress out about it too much, but this is something, again, you're going to have to be able to know and work with. Now here's our cosine function, and again we're going to go ahead and restrict this, and what we're going to do is we're going to restrict it just from this spot right down here to this spot. So when we do that, what we said was, alright, we're going to restrict our domain of cosine from 0 to pi because it would fail the horizontal line test, so we restrict the domain, and that's where we end up. So that's going to imply that the range of the inverse cosine is going to be the same thing. That's going to go from 0 to pi, and it's going to include those values. Now for the range of cosine of x, again, that's going to go from -1 to +1 and inclusive, and that's going to mean that the domain of my inverse cosine or arc cosine is going to also be from -1 to +1. Now again, we've got our table of values here, but this time we're only looking from 0 to pi. Now 0 to pi, let's kind of take a look at that from a quadrant perspective. And from a quadrant perspective, 0 to pi is going to be in quadrant number 1, so I'm just going to write that as Q1, and then quadrant number 2, Q2. So all of these values right here are going to be in quadrant number 1 and quadrant number 2. Now here's a little bit different way to represent it for some people. You might think about it from that unit circle perspective like this. So you're going to go from 0 to pi. So everything is going to be within that range, within that semicircle or that part of a bubble. And similarly to that, if you wanted to take a look at that kind of idea for arc cosine, with this piece, same kind of idea. You're going from -π/2 to pi/2, which means if you were to go ahead and draw that on the unit circle perspective, so you'd have pi/2 would be right up here at the top. But here at the bottom, instead of calling that 3π/2 because you go backwards, that's going to be -π/2. So that's just a little bit different way to represent each one of those other than a table of values. Now here, go ahead and fill in this table of values for cosine of x, and then come on back, see how you did. Hopefully you've got all of these down, you've got all of them memorized, and you can fill in this table without too much of a problem. Hopefully you have all those values correct. Now one other thing to kind of throw in there is that you always want to remember this kind of general idea, ASTC for all students take calc, or any other acronym that you've heard of, so that you remember the sign of the trig function in each one of those quadrants. Now here we're dealing with arc cosine or cosine, and cosine is only positive in quadrants 1 and 4. Now when we take a look and we restrict our domain from 0 to pi, yeah, of course cosine is going to be positive right up here, which is quadrant 1 from 0 to pi, or 0 to pi/2, but then as we go into quadrant number 2, cosine is negative over in this quadrant. So if you look at your answers from 2π/3, 3π/4, 5π/6, and pi, of course those answers are negative because that's one other way to think about it. All right, so that is just one other thing I want to kind of point out there a little bit, because again, there's so many different ways to think about some of this trig stuff, and your brain really starts working a lot and making a lot of different connections with these types of problems. So however you remember it, you just have to figure out one way that's going to work for you. Now of course, we've done sine, we've done cosine. Now let's take a look at finding the exact values of each one of these. So I'm going to go ahead and hit pause. I'm going to have you guys hit pause and see if you can come up with the correct answer for each one of these 3 problems. So how'd you do? Now again, if I take a look at arc sine, so I'm just going to kind of draw it like this. Here's my domain restriction for arc sine. So I know 2 things. One, that if I take a look at 1/2, that's obviously positive. So sine is positive here in quadrant 1, and it's negative down in quadrant 4. So my answer has to lie in quadrant number 1. When I look at B, I've got the arc cosine and -1. So again, if I take a look at arc cosine, so arc cosine is going to be limited to this piece of the unit circle from 0 to pi. And since it's -1, that's actually right over here at pi. And so that is going to be my answer for that one. And then our last one, when I have arc sine of -√3/2. So here, I want my answer because remember, I'm limited to quadrants 1 and 4. Now, if I want my angle to be negative, to have a value that gives me -√3/2, I've got to be down here because remember, all students can take calc, A, S, T, C. Down here in quadrant number 4 is where sine is going to be negative. So that means if I'm thinking about this, I want the angle down there in quadrant number 4, that's going to give me a sine of -√3/2. Now, if you totally get stuck on that, here's kind of another way around that. If you recognize, like, oh, okay, that value down here, arc sine, is -√3/2. So sine, remember, is that relationship of the opposite and hypotenuse. So I'm going to have √3 over here and then 2 for this piece of it. Now, right here, your y-coordinate has to be negative, so that would be the value that would be negative. Now you should remember though that that's going to be in the 60-degree family, so this reference angle right here would be 60 degrees. Now since I'm moving backwards into quadrant 4, that would give me the value of -60 degrees or -pi/3. So that's just a couple different ways to think about that. Now we've done sine, we've done cosine, so of course we've got to take a look at tangent. Now, same deal for tangent. Tangent's going to have its domain restricted, and we want one cycle. So we're going to keep the cycle between this spot right here, -pi/2 and pi/2. But unlike sine, at -pi/2 and pi/2, we've got asymptotes for tangent, which means when we write this, we're going to have a soft bracket this time because that can't be included in our domain. So we're going to restrict the domain of tangent to -pi/2 to pi/2, which means, again, that's going to be the range for your inverse tangent. So -pi/2 there, and pi/2 with soft brackets. Now the range, the tangent function, remember the tangent function, the range on that is going to be from -infinity to infinity. And then the domain of arctangent is going to have that same value, from -infinity to infinity. Now again, here are the common points around the unit circle, so go ahead, take your time, fill those out, and let's take a look kind of, these again, -pi/2 to pi/6, all of those are going to be in quadrant number 4. And then from 0 onwards, so pi/6 all the way down to pi/2, we're going to have answers that are in quadrant number 1. So all of these, again, similar to arc sine, you're going to have answers that are in quadrant 4 or quadrant 1. So go ahead and fill these out, and let's see how you did. Now, sometimes for undefined, people will just write the empty set, so they might use this symbol right here, a 0 with a slash through it. Both of those mean the same thing. Now, if you have trouble remembering this one for tangent, here's kind of how I think about it a little bit. If there's a 3 in the denominator, then that's all I have right for my answer. It's just this 3 part right here. But if I have a 6 in the denominator, then both of these, I have a 3 and a 3. If I just ignore the square root, 3 and 3 add up to 6. So that's what the denominator is. So in the pi/6 family, that's kind of how I remember that with tangent. Whereas for pi/3 family, I have a 3 in the denominator. So that's all my answer is going to be, is have the 3. Both of them have square roots of 3 as part of your answer. But one of them, if I just look at the individual integers, is just 3, and the other one has a sum of 6, which is in the pi/6 family. So that's just one way that I remember that real quickly. Now, of course, we've got to go ahead and see how you would do with that. So let's check out and try these couple problems right here and see how you do. Go ahead and hit pause, and when you come on back, let's check out your answers. So how'd you guys do? Hopefully you got both of these correct. Now you have to be careful because remember, arctangent of -1, you want one of your x or y values to be negative, which means you're going to have to be in quadrant 4, so you can't call it 7 pi/4 because of the domain restriction on arctangent, so your correct answer is -pi/4 or -45 degrees. For arctangent of √3/3, that would give you pi/6 or 30 degrees. So hopefully by now, you understand how to find the exact value of inverse sine, cosine, or tangent for different values around the unit circle. Thanks for watching, and you guys have a great day. Peace out.